During the past 5 to 6 years, I've been automating a number of tools in both my woodworking shop and my metalworking shop in order to improve the efficiency of these machines, to make them more accurate, to speed up their operation, to give me smoother finishes, and to enable me to complete projects which I could otherwise not have been able to complete. The machines I've automated include this Automated CNC Metal Mill for machining parts out of aluminum, plastic, and other metals, an Automated Accu-Slice System for the accurate slicing of thin boards on the bandsaw, an Automated Rose Ornamental Lathe for carving unique designs on the top, bottom, and sides of projects. On my latest project, an Automated CNC Router System for carving some unique designs of my projects. In the future, I do anticipate producing some additional automated tools for my shop. Originally, I was planning on describing all of these 4 tool automation projects in this video, but this video would have just been too long. Therefore, I decided to split it into 4 additional YouTube videos, each one describing each of these 4 systems. In this video, I'll provide a brief explanation of each of these 4 machines. For additional details, please watch one of the 4 other videos, which will describe each of these 4 machines in more detail. In each of these 4 additional videos, I'll describe each of these systems, how I designed and developed them, comments on what I would do in the future if I were to make this system, accessory jigs that I developed for use on these systems, and examples of projects completed with these systems. I have made several other YouTube videos describing these systems in detail, and I will list these videos and other reference materials for each of these automation tools in the description section of these videos.
I did purchase several software packages and some additional tools to enable me to design and build all of these automated tools. My first purchase was the Fusion 360 CAD/CAM software for designing my projects. This software does have a steep learning curve, and even after 4 years, I continue to learn new features of this software. This software enables the 3-dimensional design of my projects, and it can also generate the G-code which can be downloaded to the mill for the machining of my designed projects. This software can also generate the STL files for my 3D printers. Here are just a few of the many projects that I created with this software. This is my initial design of the Automated Rose Ornamental Lathe. This system was later revised and a 4th axis was also added. This is the egg holder that I designed for the Automated Rose Ornamental Lathe to permit the carving of designs on any side surface of my wood eggs. This is the rotating 4th axis assembly that I designed for the Automated CNC Router to enable the carving of designs on the surfaces of the wood eggs. Note that I can rotate the main plate in this drawing to determine the range of motion required. This final drawing is the jig that I made for the Automated CNC Router to carve designs on both the top and bottom of the wood eggs. In addition to the Fusion 360 CAD/CAM software for designing my projects, I also purchased the VCarve Pro software from Vestic for the 3-dimensional design of projects. This software is mainly used by woodworkers using their automated CNC routers, but I have also been using it to design projects for the Automated Rose Ornamental Lathe, and I have found it to be quite useful. However, both the Fusion 360 software and this Vestic software have a pretty steep learning curve. I have spent many days and hours learning these 2 software packages. Thankfully, there are many YouTube videos describing the use of these software packages, and I continue to learn new capabilities of the software packages. About 4 years ago, I did purchase a CNC metal lathe from Tormach. I used this CNC lathe to produce many parts for the Accu-Slice system that I previously marketed and sold. But after closing down the Accu-Slice business, it was no longer needed, so I did sell it. However, I still have a manual metal lathe which suffices my needs. Probably the most valuable addition to my shops in the past 3 years have been the 3D printers. I purchased 2 of the bamboo 3D printers and a larger Anycubic 3D printer. What I find myself doing more and more is designing my projects using the Fusion 360 software, then printing out the designs using my 3D printers. This gives me the opportunity to test out my designs and modify them before I actually machine them on the mill. This saves time and controls the cost of the metal used to machine these parts. My first automation project was to convert a Precision Matthews manual metal mill to a fully automated CNC mill. This conversion occurred in the winter of 2021. I purchased the parts, servo motors and software to complete this conversion from a number of different companies, which I will fully describe in the second video of the automation series. I produced a detailed YouTube video series which describe each of the steps for this conversion, which will be listed in the subsequent video. For this first automated mill project, I did not need to do any machining or software development. I did need to design and build an accessory cabinet to house all of the servo motor controllers and computer control boards. This cabinet was mounted on the wall next to the mill. This first automation project was a good introductory project for me to learn the process of automating a machine, learning about servo and stepper motors and also software capabilities. I have been using this automated mill extensively in my shop to machine the parts that were required for the design and assembly of the other machines, which I will be describing in the remainder of this video. For most of my machining, I have been using aluminum, but on occasion I have also machined some other materials including Delrin plastic, brass and steel. I usually design my projects using the Fusion 360 software, which can also generate the G-code needed to operate the automated mill. I usually 3D print out my designs created by the Fusion 360 software using one of my 3D printers. This enables me to test out the designs and make revisions before I finally machine the parts on this automated mill. I originally designed the manual version of the Accu-Slice system in 2017. The Accu-Slice system is used to safely slice thin and accurate slices of wood using the bandsaw. I had also developed many accessories for the Accu-Slice system, including the Accu-Wedge system, which is used to accurately cut the wedges used for segmented wood turning. In 2021, I developed the first version of the Automated Accu-Slice, followed by a revised version in 2022. The Automated Accu-Slice system enables the automated slicing of any thickness of board on the bandsaw. A stepper motor powers the board through the bandsaw blade at a slow and consistent rate. As a result, the boards sliced on this automated Accu-Slice are not only sliced to an accurate thickness, but the cut surfaces are quite smooth, requiring little or no sanding. The design and construction of both versions of these automated Accu-Slice systems are described in a series of YouTube videos which will be listed in part 3 of this video series. The development of this automated Accu-Slice system was much more involved than the automation of the mill. I designed all of the components using the Fusion 360 software, and then I machined them using the automated mill. In addition, I developed all the software to operate these systems. I used an Arduino board as a computer to control the operation of the stepper motors. One stepper motor was used to power the board through the bandsaw blade, and a set of 2 stepper motors were used to adjust the thickness of the board being cut. I used a next-gen control panel to visualize the cutting operations, and I wrote all of the Arduino and software code which was required to control the operation of the system. As I mentioned earlier, this project was much more involved than my first automated mill project. I had to not only learn the procedures for the operation of the stepper motors, but I also had to learn the Arduino and next-gen software programming. I used this automated Accu-Slice system to slice the thin sections of the wood boards used for the many segmented projects, as well as the dizzy pattern projects which are featured in many of my videos. I had purchased the components to assemble a manual Rose Ornamental Lathe many years ago, but I did not get around to this project until the second half of 2024. But when I started to put a system together, it made sense to automate this Rose Ornamental machine. Over several months, I designed and then redesigned the components for this system. My first prototypes were made out of MDF, but for my final version I machined the parts out of aluminum. All of the parts were designed using the Fusion 360 software and machined on the automated mill. Again, there are a series of YouTube videos describing how I designed and produced this system. While using the system, I saw the need to develop several accessory jigs for the system to enable to cut patterns on projects such as the wood eggs that I have been making for years. I also designed and developed jigs to enable the printing out of designs on both the side and face of projects, a jig to hold a pen for scribing the designs, and other jigs for the holding of various items for decorating using the Automated Rose Ornamental Lathe. I will be showing these accessory jigs in part 4 of this video series. I developed 2 different software systems for controlling the operation of the Automated Rose Ornamental Lathe using a series of stepper motors. For the first control system, I once again used the Arduino computer board and I wrote about 12 different programs to generate the design patterns. After I began using the Automated CNC Router, I saw the need to use the VCarve Pro software from Vestec to enable the carving of more elaborate 3D patterns on the face and sides of my projects. Therefore, I generated another separate program to enable the use of this software. The Part 4 of this video series describes the development of this system, the design and use of the accessory jigs, and I will demonstrate the use of the two software systems to generate a wide variety of projects using this new Automated Rose Ornamental Lathe. Earlier this year I began the development of my new Automated CNC router. There are many good automated CNC routers on the market, but I chose to produce my own version. It probably cost me more to make my own system than to buy a commercially available unit, but I did add some capabilities which are not available on the commercially available systems. For instance, I am now able to cut and carve projects up to 10 inches tall. In addition, I have made many accessory jigs for this system to enable the holding and carving of my many projects. I am currently in the process of designing and testing a new 4th-axis rotary accessory for this system. There are many good YouTube videos available from other authors describing how they made their systems, and I did refer to many of these videos for their ideas when I was designing my system. I designed my system to be able to cut boards from 24 inches wide up to 36 inches long. My first prototype of this system only enabled me to carve projects up to 4 inches tall. But soon after developing this system I saw the need to carve some taller projects. So, I remade the uprights to enable the carving of projects up to 10 inches tall. The system once again uses stepper motors and the main computer board is the Arduino Mega board. I am using the VCarve Pro software to design my projects and generate the G-code. I am then using the G-Sender software to control the operation of the stepper motors and download the G-code to the Arduino board to operate the system. In the final part 5 of this video series I will describe the design and development of this new Automated CNC router, the various accessory jigs that I have developed for this system, and I will demonstrate the operation of the system and show many of the projects that I have created using this system. This video is just an introduction of the automation of the 4 machines described previously. The next 4 videos in this series will describe each of the systems in more detail. I will give details on how they were produced, the parts that were required and the software that was required to operate these systems. I will also discuss some improvements that I made and suggestions for other changes that could be made to improve the systems. I will then show the actual operation of the systems and demonstrate a variety of specialized jigs that I developed to use with these systems. In the description section of each video, I will list the other related videos that further describe the design and manufacture of these systems as well as some of the projects that were completed using these systems. Finally, at the very end of these videos I plan on showing a large number of projects that I have completed using these systems. My intent is that these projects will give other operators ideas to make their own similar or related projects. Once again, thank you for watching this video. If you have any questions or comments, please contact me via email.